All right, let's take a look at this aircraft. So one of the things we have to do is figure out, is the aircraft balanced enough to fly safely? And in order to do this, we have to do a little bit of math and analysis. So we are going to focus on the math portion, and then we'll talk about the analysis portion later this week. All right, so this is the datum line, and it's kind of a reference point we use in the airplane. It's the location of the firewall behind the engine, between the engine and the cockpit. And the reason they choose that, it is very likely that that position will not change as the aircraft is used and modified through its lifetime. The firewall is a static part that won't move very likely. So what we have to do is identify the moments and the weight of the plane. And really what we're shooting for is we want the center of gravity to be a little bit forward of the center of the wing. So like right where that light is, we want that center of gravity right about there. And if it's shifted to the back, then that's a problem, and it's shifted forward, that's a problem, because the plane will not be stable for flying. So this is something that pilots have to do, and we're going to emulate that now. All right, remember our formula that moment is equal to force times distance. So you'll have a table like this. Normally these would be something you filled in. You would need to know the empty weight of the plane, how much the pilot weighs, if you have a co-pilot, how much that co-pilot weighs, how much fuel you have in the aircraft, how much your first and second passenger weigh that are sitting in the back seat, and your luggage, how much does that weigh. So those are the things you need to think about. And then these distances here are the distance from that datum line from the firewall. So we can see that the pilot and the co-pilot are 37 inches from the firewall, and the fuel is 45 inches from the firewall, and then the passengers are about 73 inches from the firewall. So on like that. So usually these numbers are very static, but except for the weight of the plane, the empty weight of the plane, everything else here can change. So what the pilot has to do before they can take off is they have to find the moments involved here. So they would take the weight of the plane times the distance from the firearm, and this is from the firewall. This is where the center of gravity should be for the empty weight of the plane. So you multiply these two numbers, and then you get 54,604. So force times distance. You do that for each item all the way down your list, finding the moment for each item. And then at the very end, what you're going to do is you're going to add up all of the weights to find the total weight in the plane, and then you're going to add up all the moments to find the sum of all the moments and how they're acting on the plane. And using these two numbers, you can find out with a reference chart if that plane is going to be safe to fly or not. So in this exercise, I want you to find the total weight, and I want you to calculate the total moment for each item, and then the total moments for every item in the plane. All right, that's enough on that. Thank you for watching.